So most people know about me and the T56 stuff, but I want to talk to you a little bit about the V160 and a couple parts that I'm developing for it to make some of the clutches work a lot better, like the OS Geiken clutches and your other typical push style clutches, the multi-plate clutches. I'm working on a new bearing, or a modified bearing, I should say. It's not really a new bearing, it's just one that I modified to work with the V160.
Here are the current options you got when you come to an OS Geiken clutch. So what they provide from OS Geiken for your V160 is this alteration kit, which basically turns your pull type clutch fork setup, as the V160 is factory, into a push. So it'll basically turn that into a pusher, and it's pretty cumbersome. A lot of cars that I've driven with it, they're like an on-off switch, and they just don't work as well. And just look at them, you can tell they're just clunky. And then the other option would be to try to make this V160 bearing, which is made by Tilton, but they only make that for their clutches. So you would have to try to get this to fit based on the height of your clutch. And you know, they only offer that for their twin and their triple and their quad. So they only have 3 heights available for that. So your options are kind of limited. So coming from the T56 stuff that I've been doing, Tilton makes a bearing that's adjustable. The only problem is it doesn't fit the V160. So what I've done is I've changed the plate that it mounts to the T56 and machined it and drilled it out so that it fits the V160. So now what you have is an adjustable bearing. You can see here with this threaded rod that'll allow you to change the overall height in and out based on the height of your clutch that you're using. So this is more of a universal kit that'll work for pretty much any push style clutch for the V160. Here you can see the typical Tilton bearing, like I said, and that installs in much the same way this bearing would install, just 4 bolts to the actual front case of the transmission. But this is a set height, and this bearing allows adjustability. So you can see here this, I guess you could call it like a linchpin or whatever, that holds the bearing in place, locks it in from being able to move. So that guy keeps it from being on a move. So if I take this out, you'll see that I can spin this bearing. So if I pull my lines out of my inspection hole, I can now spin this bearing either outward or inward to change that overall bearing height. And that's what we want to do, is we want to get our bearing height matched up to our clutch height so that it has the right air gap between the two. And the one thing you always want to remember when installing one of these is that your feed line should be on the bottom. So down here, this is going to be your feed line coming from your master, and then your bleeder line is always going to be at the 12 o'clock position. So you want to have the fluid coming in and bleeding the air out the top. If you would install it like this, there's a good chance air could get trapped up here in the bearing. So you want to make sure you have your bleeder line coming off the top, and that's why you want to use that. There's 4 different holes in here that you can line this up to, but you want to line it up always with that one at like the whatever 10 o'clock position there. The first step in measuring your clutch gap is going to be to install the clutch and torque it all down, get everything installed as if it's ready to go, and then you're going to take some measurements to get the height of the clutch from the face of the block here, where the bell housing is going to mount, up to these clutch fingers. Now, I use a micrometer, and what you're going to do, like with this clutch, for example, this is an OS Geiken triple disc R3C. So you can see that the clutch fingers actually sit below the pressure plate. So for this clutch, we're gonna have to take 2 measurements. The first measurement we're gonna take is from the block face up to the top of the pressure plate. And what I usually do, and bear with me here because I'm using, holding the camera and trying to do this all at once, is I use the little guy that comes out of the bottom, and I adjust it using that. I guess it's like the depth gauge, I guess you could call it. So you take your measurement there and you just write that down, and then what you're going to do is you're going to come over here and do the same thing on the height down to the fingers. And what you're going to do is you're going to take that first measurement and you're going to subtract it from that second measurement. So I was like somewhere around 70, and don't use these measurements because I actually don't have a crank installed in this. I'm just kind of using it as a mock-up. But if I had 70, and then I'm going to take 13 off of it, so we'll be at 57 millimeters is my height from here to here. So again, measure up here, get that measurement, then subtract down this measurement. Okay, so the second step for measurement is to set up the height of the blowout bearing, and to do that we need to take another measurement. And what we're going to do is we're going to put the straight edge here up against the front of the bell housing, and remember that bell housing is where it's going to mount to the block, so that's giving us our dimension back. Just like we took our dimension from the block out to the clutch fingers, now we're going to measure from the block, technically the front of the face here of the bell housing, back to the front of our bearing. And the measurement, the way you calculate this is right here. So you take your the first measurements we took were the block to the pressure plate was 70 millimeters. The pressure plate to the fingers, we subtracted that, 13 millimeters, so we had 57 millimeters. That's our clutch height. Then you want 4 millimeters of air gap, so the total height we would want here is 61 millimeters. So that 4 millimeters is going to be the space between the clutch fingers and the face of this bearing right here. So that extra 4 millimeters that we're measuring here is going to give us our little bit of gap in between. So again, there's how you calculate it. So 61 millimeters. So what I do, I stick my straight edge here on the face of the trans. I measure back. If it's too far, I grab my bearing and I spin it back in. I take another measurement until I get that 61 millimeter number that I want, and then I lock the bearing in place with our little locker bolt, again with the feed and the bleeder line lined up vertically like that, so the bleeder is on the top, and that's it. And then once you have that installed like that, go ahead and pass your lines out the inspection hole and go ahead and slip the trans onto the clutch. So now that everything is done, as far as R&D goes with that bearing and it's all set up to go, I will be offering these bearings as kits with some of my clutches that I sell, like the OS clutches, the twin, the triple, and the quad. And you can also buy the bearing alone if you have another clutch that you want to use this with, like an Exetti or something like that. But it should work with almost any clutch because you have that ability to adjust the height. So if you want to go out, check it out on my website, grannasracing.com. You can purchase right through there.